Okay, so on this problem, I did not finish it correctly, and we need to make sure we fix it in our notes. So an arithmetic sequence has a first term of negative 10, so we've got a sub 1 equals negative 10, and a common difference of 20, so d equals 20. We want to use the first four terms of this sequence to write a series and develop the formula for the sum. So the first four terms would be negative 10. Negative 10 plus 20 would be 10. 10 plus 20 is 30. 30 plus 20 is 50. So these are the first four terms of the sequence. And when we write that as a series, we just put a plus sign between each number and add those up. So we're adding up the first four terms of this series. And when we add it up, we get 80. Now, we developed a formula for this by adding the first term and the last term and figuring out what that was. That was 40 here. And then we add the next term and the next to the last term, and that adds up to 40. So you can see for every two numbers in the series, they add up to 40, which means you can just multiply 40 by n over 2, the number of terms in the series divided by 2. So we have s sub 4 is equal to 4, which is n, over 2 times the first term plus the last term, which is 2 times 40, which is 80. So we're just saying this is how that works. So now when we want to find the sum of the first 11 terms of the sequence, we don't have to write out all 11 terms and add them up. We just do that using the formula that we had, which is s sub n is equal to n over 2 times the first term plus the nth term. All right, so to use this to find the sum of the first 11 terms of the sequence, we need to find out what the 11th term is, because we have to put that in to the formula right there. So remember, when you have an arithmetic sequence, to find the 11th term, a sub 11 is equal to a sub 1 plus 11 minus 1, or 10, times the common difference. So a sub 11 is going to equal negative 10 plus 10 times common difference, which is 20. So that's 200 minus 10, which is 190. So we know what our a sub 11 is now. We know what our last term is. So s sub 11 is going to be 11 over 2 times first term plus last term. So that is 11 halves times 180, which is going to be 11 times 90, which is 990. Okay, so what I wanted to look at was this, how we found the formula for adding the first n terms of a geometric series. First, we wrote down what a geometric series looks like. So you have your first term, and then you add the next term, which is a sub 1 times r. R is your common ratio, your geometric series. So you're multiplying every term by some number to get to the next term. So the first term is a sub 1, second term is a sub 1r, third term a sub 1r squared, fourth term a sub 1r cubed, and so on. And you're adding all those up. And you want to know, well, how do I write some kind of formula to find the sum of the first n terms of a geometric series? I sure don't want to have to write all that down and, up to 150 million terms. That wouldn't be fun. So what are we going to do? We're going to do this little trick like what you did when you learned to write repeating decimals as fractions. We're just going to rewrite what I just wrote, and this time we're going to multiply the whole thing by r. So instead of s sub n, we're going to have r s sub n. We're going to multiply every single term by r. All right, and when I do that, I'm going to have r times s sub n equals a sub 1r plus a sub 1r squared plus a sub 1r cubed plus a sub 1r to the fourth plus a sub 1r to the fifth, and so on. And then when I had a sub 1r to the n minus 2 and I multiply that by r, that means I'm adding 1 to the exponent. So I'll have a sub 1 r to the n minus 1 And then when I multiply a sub 1 r to the n minus 1 times r, I just get a sub 1 r to the n. So this is what I have. Now I'm just going to scoot it over so that all the terms that look the same are right under each other. So if I subtract these two equations, I'm just going to put a line under the whole thing. I'm going to subtract. On the left side of the equal sign, I've got s sub n minus r times s sub n. And then on the right side of the equation, when I subtract, all these things that look exactly alike disappear. So, and in the dot, 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 we have this a sub 1 r to the n minus 2. So all those things disappear, and all we're left with is a sub 1 minus a sub 1 r to the n, because that's what's left over here on the end. So now I have my formula for s sub n. I'm trying to find a formula that will tell me how to add the first n terms of a geometric series. So I need to isolate s sub n. That's what I'm looking for, a formula for s sub n. So I'm going to factor out the s sub n on the left side. I'll be left with 1 minus r. And on the right side, I'm going to factor out the a sub 1, and I'll have 1 minus r to the n power. And so s sub n is going to be a sub 1 times 1 minus r to the n over 1 minus r. So this is the formula for adding up the first n terms of a geometric series. So for the arithmetic series, the sum of the first n terms was n over 2 times a sub 1 plus a sub n. So that was when we did the trick where we added the first and last terms, the second and next to the last term, and so on. So that's the formula for to add up the first n terms of an arithmetic series. For a geometric series, it's what we just found. So the sum of the first n terms of a geometric series is equal to the first term times 1 minus the common ratio raised to the n power over 1 minus the common ratio.